geothermal resources. Here in Kenya, there is a lot of geothermal resources that is taking like 30%. But before I go there, I explain a bit about. Okay, I want to talk a bit about this alliance. We have Alliance for Industry 4.0 in Smart Manufacturing. Who are we? Because it is very important to understand when we talk about this alliance. What do we want? It is expert people came together and try to see how they can be able to generate some solutions to Africa problems, because this alliance can be able to expand progressively to be able to reach to all the stakeholders. But the main idea is to see how can we be able to work on smart manufacturing industry 4.0, but on the priority of what we have in Africa, because in Africa we have a lot of resources. Then we need to know what can we be able to achieve at national level or at international level, and bring all Africa together, then to be able to deal with the African problems. When you look at this alliance, we have an objective of sharing information, knowledge, consultants, and be able to discuss something related to application in industry, to discuss something related to digital technologies, something related to education and training, and as well as we are here for the policies now, to discuss again something related to policy, because these technologies, if we look at, I think 2 weeks ago, there were a certain decree in the United States where Joe Biden is trying to talk about policy on AI. We received a communication from Kenya, because I work with the Africa Standard Organization, to work out with the team from United States, to be able to work on these policies, to see how AI will be guided for also for Africa. There is a policy country like Rwanda has made the policy for artificial intelligence. I believe Kenya is working on it. I believe Tunisia and other countries are working on it. So those are the part of the things we need to also look at it. And also we need to understand Africa in general, because we have a lot of potential as Africa countries. We have natural resources, but the question is, other people are taking advantage of this smart manufacturing and industry 4.0 to be able to bridge the gap. But for us Africa, some of African countries are not even taking the step. Some are taking the step, but slow. So if we wanted to be competitive with other Africans or the globe, we needed to make sure that we integrate in our manufacturing the industry 4.0. Definitely, we needed to enhance. We have youth, we have a young population in Africa. We needed to make sure that we can be able to increase employability, we can improve the sustainability, because what is more important for us, we needed to go to these technologies to try to understand why Africa is not developing. Is because we are not building capacity in virtual reality, augmented reality, digital twin, artificial intelligence. Those are the things we want to build capacity, so that we can be global competitive. Because we can be competitive if we build our capacity and we go to develop this ecosystem. Because these technologies are disruptive, but even if they are disruptive, if you put them together, if you integrate them together, they can be able to give you important value. So my presentation today, in line with this alliance, I am trying to look at, we have a geothermal in Kenya. This is potential, not only in Kenya. If you move, you look at the Rift Valley until you reach to South Africa, you have these geothermal resources. This is green energy, but this green energy, it comes from underground on a dry rock. But you need to go to 3,000 meters to be able to get this heat, this geothermal to heat the rock. After you hit the rock, you can be able to get this energy. If you look at Kenya, as per 2023, Kenya was having a geothermal contributing 950 megawatts, but out of 3,000. So it means it's 30%. Kenya wanted to have green energy up to 51% by 2030. I read a certain newspaper from France, I think it was in August or September, which was saying Kenya is one of the countries which has more green in the energy mix in the world. So, but Even if we say we have 30%, there is a need to reach to this 51. To reach to this 51, there is a lot of needs. To be able to reach there, we need to understand what is the challenge. The challenge in this geothermal is if you want to drill one well, you need 5 million US dollars. If you need this 5 million US dollars to drill one well, and to make a plant, you need to do 20 or 30 wells. So this means for you, you have a plant where you have maybe 140 megawatts. But here, you need to know when you are trying to go to this drilling, there are 3 people involved. There is a geologist, there is a geochemist, and a geophysics. These people, when they have to find out where is this, because what is important is this rock. Because there is underground, there is this steel. You need to know where is exactly the rock. You go to 3,000 meters, you invest your 5 million, you find cold water. So why cause this? Some countries, I have an example, like for example, in Rwanda, they tried to drill, they went to 2,500 meters, they found cold water. So the 5 million went. So now, here, what is making this to happen is because the geologist and the geologist, geochemist, and geophysics need to sit together and agree, looking at, for example, geologists will come on the surface, look at the stone, look at the ground, look at the fumaroles, and check if there are some smoke coming from underground. Then you can be saying, I think here there is a geothermal. Geochemist will come and take water, take other chemicals from that ground, and then again take it to the lab and say, according to how I am seeing in this water, there may be geothermal here. A geophysicist will come now with an instrument to try to see magnets, to measure the magnet and other resources to see whether there is geothermal. But what is a challenge here? When you look at this traditional method of doing this, there is a problem of skill upgrading. That is one of the problems. You know, the people in this geothermal exploration, they are technicians who will go to the site, and they are experts who will stay in the office. Now the people who will be, the people who will go to the ground will go with the equipment, take the data for geologists, get data for geochemists, get the data for geophysicists, then you bring it to the office. But now here there is a missing of time, because this person will take a USB or a computer, put the data, go to the office. If office is in Nairobi, you wait. If you find there is a problem, you come back and so forth. But what we try to look at so that we solve this problem, which generally this is how the system works. You have the lab, people who will do analysis, geologists and experts. You have the technologists or technicians who will go to the site. And then this technician will go to the site, take the data on USB, take some liquid, take some steel, take some logs, take to this office. This will take a lot of time, and also the skill these people are having, because when you are taking water you got from here, it may have meat or have made some other materials from industry and from other places. You cannot be able to guess whether this liquid you are getting here is necessarily meaning geothermal. So these people from the site, they will bring information on the quantities, to understand the log, to understand the shape, to understand the accessibility. Because when you are drilling, you drill vertically, and then you go direction or you go horizontal. Because you may decide, you may find the log is maybe 1 kilometer from here, but you find it is not possible to drill from this location. So it means you need to do it when you go maybe 1,000 here, then you take direction. Then to know where this rock is. That is where the industrial 4.0 technology could come to help us. Because when we are doing this exploration, the challenge we have, we don't have a method like augmented reality where somebody can be able to, when you are on the site, your information can be sent to the office with IoT, with the other infrastructures. Then when it reaches there, you can be able to compare what you have modeled, what is written in the books. Then you compare with what you are seeing in the site, you augment more information about it. Then you do data analytics so that you can be able to use artificial intelligence. So it means if this data is on digital, somebody is on the site as a technician, he's moving. Maybe the lock is at a certain place. He can be communicating with the people in the office. The people in the office has the virtual platform, and this person is able to look at this in augmented information. So he can be able, if he comes with an information, is as a photo, it can be augmented to be a video and to have more material on it. But for this to happen, we need to know what are we trying to propose. Because one, we need to have a very good workforce. Because these people who should be working on this, because there's a problem of aging, the expert, they have studied. So it means now the technology, there is a need for the skill upgrading. Because this artificial intelligence, I published my first paper of artificial intelligence in 2007. When I published this paper, that time, even my professor told me, this is not really something to talk about. Even actually he joked on it and said, this artificial intelligence you are talking about, even your wife or your children will not listen to you. But I see you are listening to me, right? When I'm talking about artificial intelligence. So it means there is an improvement. What he told me, I think it cannot say artificial intelligence cannot listen to people. But there is a cyber physical system. I think my colleague Sasha, as expert of Industry 4.0, when we talk about enablers for Industry 4.0, cyber physical system, artificial intelligence, IoT, those are the technologies we need. So that we need to have data exchange on a real time. Because what we need is to make sure that this is geological data, hydrogeochemical data, geophysical data are transmitted in real time. So it means the geophysicists and the geochemists can be able to discuss and be able to improve what is going seen at the remote area. So our proposal is to have a comprehensive integrating advanced technology where we are able to collect the data using all the equipment, camera, tablet, and so forth, because the people generally they go and pin the data in the tablet, but they have to carry it to go where the office is. But for us, we want to do it. We use the 5G, we use the device-to-device communication, we use augmented reality. Then we build a virtual model, which will be having a virtual reality and augmented reality. And then we have the data, we make a twin, a digital twin of the site. And then we bring this model to artificial intelligence to learn it from the data we have collected from the previous drilling. When we take this data, it means the people in the office will be able to receive an information. We are not eliminating human beings, because one of the problems of when we talk about artificial intelligence is the contribution of human beings. Human being still is an expert, will remain there, but he will get more insight about this virtual platform. So, what we tried to do in our office as one of the work when we talk about this virtual reality, somebody can go, if you see somebody can navigate inside the virtual platform and he can be able to move. You can be able to, what you think about. If I go to the site where I want to build a geothermal plant, what do I need? I need maybe solar to give me the energy to start to operate my machine. I need to have the tools and other things. So this is, in this model of virtual reality, you can be able to teach young people how you can operate geothermal. As I started to understand how to prepare the ground, this is one of the preliminary work we are doing for climate change to show people can also be able to use the heating with the solar and with heating hot water and so forth. But for drying, definitely for drying the coffee, for drying food and the other things you want to export, avocado and other resources. But what I'm talking about here, I'm trying to say teaching virtual reality is good for teaching with less resources. Augmented reality will help us to be able to go to the site and augment the information about the existing site. IoT will help us to be able to transmit the data on real time. The device-to-device method will help us to have the system communication, the sensors communicate to systems, and also the people who are on the site can be able to have communication system without necessarily having internet. So this is one of the projects we wanted to leverage on, and I wanted to show you the team. We are together in Alliance. Sasha, Adele, and myself, another team in different African countries. Thank you so much for giving me a chance to talk to you.
Thank you.
Thank you.